A really important concept that we need to cover is handling errors. Now we may ask ourselves, what is an error? And we may also hear the term exception. So error and exception, what are they and why do I need to worry about them? In programming, errors and exceptions are related to exceptional situations. So let's go ahead and do that. Exceptional situations in our code. All right, so exceptional situations. This would be where, as we're programming, we are unable to identify all possible issues that might arise. This is situations like when we make a remote request to a web server, an API, a web service, or something that is handled by a third party. At any time that we make those requests, we may not be able to tell whether or not that web server, API, or web service is going to actually respond back to us. We may write our program dependent upon something coming back from that web service, and if we fail to handle the situation where that web service or web server does not respond to us, we are going to end up with an exceptional case. In other words, something we didn't think about or something that we chose not to handle that is going to end up blowing up our script or stopping our script from running. So that's one situation where we are relying on a third party that may or may not respond. We also have situations where we might be writing to the disk. So let's go ahead and let's note down some of these. So calling an external resource. So that would be a web server, API, web service, something like that. So calling an external service. The next thing might be using an I/O device. So that would be input-output, right? An input-output device. And an input-output device, that could be things like a hard drive, a file system on a hard drive, a particular file. Anything like that would be something that could potentially cause an error because we don't have total control over that. The operating system does. So if we have a hard drive failure, that could cause an error in a running application. It would probably just shut down the entire operating system if that happened. Or if we don't have access to the file system for some reason, whether the file system is busy because the operating system is in the middle of doing something complex and is utilizing a lot of resources, or if we can't get to a file. The file doesn't exist or the file is corrupt. So let's note that. Corrupt or does not exist. The other thing too is permissions. Perhaps we do not have sufficient permissions to access things. That would be the file system, files, specific files, or different locations within the file system, or on a web server, API, or web service. Maybe we're calling a service that we don't have permissions to with our account. The service exists, but we just don't have the right to access it. So these are all some of the situations that we could run into. There are a lot more, such as runtime errors. So let's go ahead and put that up. Runtime errors. And these are going to be things like bad calculations. That could be like a divide by zero situation where we're dividing something by zero and that's going to give us an error. Or maybe we index an array outside of its bounds. So that's going to be another situation where we'll get an error. So these are only a few of the situations that might cause errors that we should probably handle in our software, or at least think about handling and deciding whether or not we need to handle it. Now the big thing here is the decision as to whether or not we handle these errors in our program. And what the side effects would be if we do handle them and what will happen if we don't handle them. In most cases, when we're dealing with JavaScript, if we run into an error or exception, what is going to happen is our script is going to terminate. Now what I mean by that is, let's go ahead and let's cause an error in the script that we're writing right now. And we can cause an error by using what we call the throw statement. So throw is a keyword that we can use in order to cause an error to happen. So the situations we described up here are caused by something else. But we ourselves, as the developers of the software, if we determine that an exceptional case has happened, we have the right to also throw an error, just like all these other situations might throw an error. And we just do that by using the throw keyword. And I'll show you how to use that in our code, but we're just going to go ahead and create an error right now. So let's just do throw, and we'll just call this my error. And then terminate that with a semicolon. Now when we run this script, what we're going to run into is an error. And you can see, instead of my script running to end, we've got an error happening here. So let's show how that happens and that we're actually terminating the script. Let's do a console.log, and then let's say this is before the error happens. And let's terminate that. And then let's do another one, and let's put it right after it, and this, let's change it to this is after the error happens. Now inside of our IDE, we can actually already see that there's something up, because this text right here is darker. It's muted compared to the text up here. And that's because our IDE already notices that if we throw this error, the code down here is unreachable. And that's because it knows that if we throw an error in our script, the script terminates right there at the error. And we can see that happen by running this code. And we will see that we will get that first console.log that says this is before the error happens. Then our error is thrown, my error, and the script terminates. We never see this last line because it's unreachable. We can't get to it. So here we see that throwing an error. Now, here in this example, we are simply throwing the error, and the error is really just a string. Well, behind the scenes, when we say throw, JavaScript is actually wrapping whatever string we provide inside of an error object for us, and that error object is actually being thrown by our script. And if it's not handled, if it's not caught, and we do something with it, what's going to happen is our script terminates and the rest of our script never executes. Now this is okay if our script depends on whatever threw the exception or the error. So if we're calling an external web service, and if we don't get results from that web service or API call, and we don't want our script to continue executing because this is a terminal failure, then we may just want to throw an error and have our script completely fail, and then the user has to reload the browser or do something to restart that script. And usually that's reloading the browser or reloading the page in the browser. Now, that's not necessarily the best way to handle things, but sometimes completely letting your script fail is acceptable. Runtime errors, those are usually errors that you don't notice or don't catch in your testing because it's caused by some exceptional situation. Like you may not catch a divide by zero because you're getting user input and you didn't think that a user might add zero as the divisor. And so you'll end up with a divide by zero. And this is where we rely on the developer to really think about what they're creating, where they're getting their data, and how they're processing that data, and then trying to figure out what errors they might have at runtime due to some of these exceptional situations. Now, right here we've got ourselves a throw statement which creates us an error object from this string. Now let's figure out, or let's learn how we can catch errors. So in this situation, we've got some code that throws an error. The way we catch an error and handle it without causing our script to completely crash, like we see right here, is by using what we call a try block. And this try block is where we put code that may cause an error. So here we're throwing an error. Let's go ahead and put it inside of the try. Once we have code that could throw an error, which means if we're calling an external API, we should put the code that we use to call that in here. If we're writing to a file on the hard drive, we should put that code inside of our try block. That means inside of the curly braces that follow the keyword try. If we're trying to access that requires permissions or has security wrapped around it, again, we should put it inside of a try. And if we're going to do division or anything like that, or index an array where we might potentially go outside the bounds of the array, we're going to want to go ahead and put the code that does that inside of the curly braces of the try. Now this won't necessarily stop an error from happening. If I run this code, we're going to see it still errors out. And that is because the try just simply wraps the code that might throw an error. It doesn't handle the error that will be thrown by that code or potentially thrown by that code. For that, we have to go ahead and add a catch block. And the catch block is another block that right after the try will catch the error and allow us to do something. So I can do a console.log and then I can send a message, an error has happened. And I can put that message out, and then if we run this code, we should see this is before the error happens. An error has happened, and now we actually get down to this last line of code or this last statement. And that is because we're actually handling the error after it happens, and that is by using this try block and then having a catch to catch the error right after. The cool thing about a catch block is that if an error is thrown, it will catch that error so that we can do something to handle it without our script imploding on itself. We can also capture the actual error that was thrown by providing a parens with the variable that we want to hold the reference to that error in. And it's kind of common practice to use error or error in order to capture the error that happened. So let's go ahead and let's log that error and see what we get here. And let's log error, and then let's run our script. And here we see this is before the block happens, so that's line 9. We have our try happen, 11 throws the error, 12 catches the error and gives us a reference to that error inside of our catch block. So now we have this error that we can get to. We get line 13, which says an error has happened. And then 14 actually prints out the error to our console, and we see the actual message that we provided in our original throw statement. Let's go ahead and use the debugger. Let's put a breakpoint right here at 14 so that we can stop our debugger at line 14 and actually examine this error and see what we've got. Here we've got our error. Here's our call stack. We've got our loaded scripts and our breakpoint right here. And let's go ahead and look at this. We've got the error handling right here, loaded scripts. Now let's see if we can't get this to come up here. We got variables. We've got this, which refers to the global object. And then we've got our error right here. And the error is simply a string called myError. And it is an object called error, but it's just a simple error. That's all we've got there. What we'll do is, in our next screencast, what we'll do is we'll cover how to build custom errors and use actual error objects in order to hold more information about our error other than just a message. Right now, our error is extremely simple, and all it holds is the error message that we provided. Now let's go ahead and let this finish running. Click play. Let's get rid of our breakpoint. And now we can see the basics of how we do a try catch, and we catch an error and then we can do something with that error. And we'll get into more details on what we do based on what type of error when we get to our custom errors. Let's do a little bit more specific example, one that demonstrates this a little bit more concrete, a little more concrete example. Right now it's kind of contrived because why in the world would we just simply throw an error? Let's come up with something that actually provides us with a really good example of when we might have errors and how we might catch them. Let's start off with a function, and let's design our own function that does something. And let's kind of do a divide function, and let's handle a divide by 0 that might happen. Let's do our function, and we'll call it my divider. And then it takes in the two numbers, so num1 and num2. Now inside of this function, we may simply just do something like this, return num1 divided by num2 and call it good. Problem is that if we do something like that and then we call my divider and then we pass in 10 and a 0, we're probably going to end up with a problem. Oops, right here we've got the error happens, we've got our error after happens, but it looks like the divide by 0 works just fine. Let's see what we've got here. Let results equal, and then let's go ahead and let's console.log it and see what actually happened when that code got executed and what was returned by our function. Let's run it. Aha! We actually got infinity. And that is because when you divide a number by 0, you can't. And so what we get back in JavaScript is infinity. In other programming languages like .NET, Java, Ruby, and stuff like that, when we divide a number by 0, we will actually get back an exception that says it's called a divide by 0 exception, and we'll get an exception back that tells us we can't do that. JavaScript, on the other hand, gives us back infinity, which just tells us that we got back an infinite number, because if you divide a number by 0, it's infinite. It really should be an error, in my opinion, just like other programming languages. So if we're going to do this my divider function, we are probably going to want to check to see if our divisor is 0 or not. So let's go ahead and add ourselves a check first in our code to see if num2 is equal to 0. And let's go ahead and do that. Let's say if num2 equals 0, then we're going to want to go ahead and throw an error. And let's just go ahead and do a divide by 0. And let's just throw that error if we receive a 0. So before we saw that it went ahead and run and we had ourselves infinity as a result, but we don't want infinity, we want to throw an error to let the user know, or whoever's calling our function, that you can't divide by 0. It's not possible. So let's run our code and see what happens. Here, we've got this happens before the error, so this is line 9. And then when we execute line 19 and my divider gets called and we pass in a 10 and 0, this function definition gets called. And we get a check to see if num2 is equal to 0. If it is, we throw a divide by 0. Here we've got an error called divide by 0, and our script terminates. This is what I want to have happen anytime somebody tries to divide by 0. Now because my function throws an error, what the caller can do in order to make sure that they handle this situation is they simply wrap the code that could have this error happen to it. Let's go ahead and put that in here inside of a try block, and then we can catch the error using a catch statement with its own block to handle the error. Here, we've got the results divide by, or my divider function, and we're calling by 0. So we've got the same situation, but instead of our script blowing up, we can actually handle a divide by 0 error. So let's go ahead and do a console.log, and let's log that error to the console so we can see that we've actually caught it. So let's run it. Here you can say, this is before the error happens, so that's our line 9. At line 20, we actually call that function. It throws the divide by 0 error because we are passing a 0 in, and we catch that error and log it on line 23 to our console, so that's where we get this line. And then we get to our final console.log, which is 27, which means our entire script executed because we handled an exceptional case by catching the error and doing something with it. Now, if we go ahead and change this to an actual number that we can divide by, so let's divide by 2, we execute the program, we will see that this is before, so that's our line 9, and then line 20 executes. We get the result back because no error is thrown, division actually happens, and a value is returned. Line 21 logs that return, which is 5, because 10 divided by 2 is 5. And then we get 27 executing, and we see that our script did not fail because no error was thrown, but we still have it wrapped in a try-catch just in case. So this is useful if we are prompting the user in our web page through a web form or something like that for the two values that we are going to divide. And if they don't provide a 0 in the divisor, then everything executes the way it's supposed to. If they do provide a 0 in the divisor, then we end up with an error being executed, but we catch it. All right. So this is catching an error in an exceptional situation, providing code that will capture that error and handle the error gracefully so that our script does not completely fail. In this situation, if we were gathering this information from a web form, we might actually up here ask user for numbers via web form, and then we would get that data back, pull the data out of the form, and inside of this code execute it. And if there was an error, we might do something, let user know there was an error and to try again. And then we might handle or have code here that handles asking the user again. And then we go ahead and try to run the code again. For that situation, we might take this code, partition it out into another script or into another function, and have the ability to re-ask the user. It's kind of a contrived example, but hopefully you can see how the try-catch works to capture errors that might be thrown by your own code or errors that might be thrown due to exceptional cases caused by things we are calling outside of our own script, such as an API, input-output to the file system, permission errors, or runtime errors that might happen that we're unaware of. In this case, we created the error and threw it because we decided that instead of infinity, we wanted divide by 0 to throw an error.